evening, students. We are back in the course of applied descriptive, predictive and prescriptive analytics. It is a practitioner's approach. So, we are trying to look at the stuff of analytics from a practitioner's viewpoint, and we have been studying different aspects of analytics and why is it important for a practitioner, why analytics is necessary for someone who is working in an industry. That is what we have been trying to answer all this week, and we studied about systems, models and all those kind of things. And the most important thing that was established out of it was analytics is required for in practitioner in the aspect of decision making. It is a tool that helps the decision maker in making the right decisions. So, to do this analytics, you require to study the system, build models, use these models to do analysis. From the analysis, make appropriate suggestions or comments. These models could be descriptive models, which could be describing the system, or it could be predictive models, which could be predicting the future behavior of the system, or prescriptive models, which would actually look into different alternatives or evaluate different options available with the system, and so that using that information that is in front of the practitioner can make the right decision. So, we covered quite a lot of aspects in the previous lectures, and today we are going to cover what we call as something the type of models that are available in the system. Okay. So, we also already seen what is a model, and we have seen that the assumptions that are used to study the system results in the model. We seen this in the previous lecture, and using this we also try to, in our case, we also look at models in analytics. In analytics, model is also, it acts as a connector. Model very well acts as a connector. Why? Because models connect decision needs to analytics. So, why will you build a model? Why is a model being built? To study or analyze the problem and then take appropriate decision. So, that is what we talk about it as why is the model being built. So, for in analytics, model also connects your decision need to make decision to analytics. Why? Because in real life, reality is complex. Reality is complex because because of the cause effect chains in real systems. Are intricately networked and hard to comprehend. So, we have seen that the cause and effect chains of the real systems in actual system, it is intricately networked and it is very hard to comprehend them. So, because of these, what do we do is models help to simplify reality, which results in, which in turn becomes analysis become simplified. So, if you make a simplified model, you are able to do simplified analysis. So, what we do is, what do models do? Models incorporate selected aspects of the system that is to be analyzed. We only analyze what is necessary, we do not need to analyze everything. and it also involves what we call as perspectives. Perspectives means the viewpoint. You might be just looking at observing or analyzing the system, for better understanding. That could be one option. Then you might not do much. You will be happy if you can understand it better. Some people will be analyzing for improving the system. So, in this case you will be making decisions. It will result in appropriate decisions. Here you might not do anything, it might just result in better understanding. So, the perspective of the system, the perspective in which you are modeling will also determine, or the model incorporates what perspective you are trying to bring into this. The models should follow what we call as the KISS principle. KISS does not mean that going around kissing people. KISS stands for keep it simple and stupid. Okay. This is what the KISS principle stands for. Keep it simple and stupid, which means model needs to be, if we can say that models need to be as simple as possible, and only incorporate as much complexity as required. Okay. Okay. Don't overdo the complexity of the system. Why? So that rational decisions can be made. While in academic interest you might be interested in making the complex model, but for a practitioner this is the biggest principle. So, this is the practitioner's mantra in my opinion. Keep it simple and stupid. Only study what is necessary to be studied rather than trying. If you are doing research and other aspects, that is a different story. But for a practitioner who is looking at using to study the system in which some pretty much goal of the system can be reached, try to build the model only to the level of detail that is needed, and do not add unwanted complexity, just make the complexity as required by the objective of the analysis. So, there are different type of models. So, let us talk about the first model, or what we call as the network models. Sometimes these people also call this, it is also known as the strategy models, okay, or some people also call this as the long term models or whatever it is. So, typically Saxena and Srinivasan define these network models. These models are used in scenarios where connecting market needs to workflows. Okay. So, whenever you have to connect market needs, which is to a large extent, it is usually an environmental aspect. When you have to connect the environmental aspect called market needs to the workflow is the inner working of the processes. Okay. When you want to connect the workflow and market needs, or connect the environmental aspect with that of the inner working of the system, then that is where you use the network models. In simple terms, we can say that the need of the ecosystem or the environment are connected to the capabilities required by the organization to address these needs. Classic example of these, some examples would be include new product introduction, new product development, okay, product life cycle, then customer lifetime, analysis, etc. So, an example of this would be new product development. When Tata developed Tata Nano, the question obviously is that there is a need for a cheap car in the country. So, that is the need of the country or the ecosystem of India, and Tata set aside resources to produce a small car, a family car, which would actually meet the transportation need of a common man. This is how Tata Nano was produced. So, if you look at it, the need of the society was to have a cheap car, and the network model was how to build capacity within that company to build such a small car, so that the common man can buy that car and fulfill that need. So, that is an example of a new product development. Another example is product life cycle. Sometimes you might the one of the most popular model in India is Maruti 800, and it was very popular, and after some point of time Maruti 800 was stopped in India. And so, when did the company decide when to stop the production of Maruti 800? The answer was that when the regulatory norms came in and said that if it cannot be meeting the crash test and as well as the safety standards and emission norms, then the car cannot be sold. Then Maruti figured out that okay, fine, trying to change this model to fit this is too expensive, it is better to always build a better model. So, that is the time they said we are stopping the production of Maruti 800. So, the life cycle of the product was determined by various environmental aspects there, of like the regulatory bodies as well as the cost of making it safety or safety factors being integrated into the system, etc. So, in this kind of a system, network models, we are mostly focusing on taking decisions as per the requirement of the ecosystem or the environment. So, what do we focus here? Okay. We focus here on finding and addressing the market needs. What do the market want? This means what does the market want? This is the major question that you have to address here. And once you understand what is the market need, then you try to achieve that market need, so that you can get your strategic goals. So, why would Tata build Tata Nano? If lot of people buy Tata Nano, then it will increase their revenue, and if the revenue is increased, this will in turn increase their profit. So, increasing the revenue is in a large extent increases the profitability of the company, so that the company will grow. So, that is the reason why they jumped into that kind of an aspect. So, most of the decisions, remember we studied in the previous class about network layer and as well as the workflow layer, control layer, that kind of aspects. So, these decisions, strategic decisions, strategic models are used in network layer to make long term decisions. The decisions are usually of long term. When I say long term, greater than 6 months is what I am talking. Not even 6 months, let us call it just 12 months, more than a year, 6 to 12 months, 1 year, 2 year, that kind of a decision is what we are talking about. So, the network models are where you are trying to address. So, all the analytics that is done here. So, the analytics in network model, analytics focus on long term decisions. So, here you are looking at the long term behavior of the system. The second set of model that we are going to talk about is called as the capability models. Okay. So, the capability models as defined by Saxena and Srinivasan as these models assist in decision making that are internal to the organization. Okay. So if you want to make decisions that are within the organizations, so remember we had this input, process, output, and we had the feedback loops, and we had the boundary of the system. So everything within this boundary, that's we are talking about the internal to the system. Okay, that kind of decision making, which is called as, that's where we use as the capability model. So hence it is also known as introspective models. You are doing introspection, or you are thinking about yourself. Okay. So what is the main function of these introspective models? The main function is to operate, to prepare, or what we call as setup, okay, or to evolve capabilities. The main function of these models is to operate, to prepare, or to evolve capabilities that are in line with, what? Business needs. Okay. So here, so whatever is the business needs, your aim is to build capabilities, to evolve capabilities, or to operate capabilities, or to prepare capabilities, or set up capabilities. So your business needs. So in a way, it is the focus point. The focus is on efficient design and operation. Okay. And the major other aspect is like it also assumes, it also takes market and business constraints as given. Okay. So assume that, it assumes that the market and the business is known and the constraints is known to us. We already studied it and we know it, and given this, given the market and the business constraint, how to operate, how to prepare, or how to evolve the capabilities to fulfill the business needs. The how aspect is what is being focused on. Okay. So the analytics typically focus on the operational side, or the preparational side, or the evolutional side of it. So the examples of this is delivery capability of a product, capabilities of product, service capabilities, okay, manpower planning, R&D, etc. So when Tata Nano was planned by Tata, they need to decide, why, if you are going to build so many cars, how will we deliver these cars to the customers? When we deliver the car, the customers start using it. How will we do the service of this car? Where will the customer bring in? Where will be the service locations? And what will be the manpower? How much more additional people we require to build this factory, run this factory? Where will we do the R&D? These kind of aspects. So if you think about it, this is more about, okay, the how will we realize what we want to do. The analytics typically focuses on this. Okay. And there are a wide variety of models that are used in this area as related to this kind of an aspect. Okay. Now we talk about the third one, which is called as the control system models. Okay. And Saxena and Srinivasan talks about control system models are, these models address those needs to change. Okay. So this is the most interesting part of this is, by the way, previously in the capability model, it is in the, this originates in the capability layer. Okay. Similarly, the control system models, they originate in the control layer of decision making. So, when you talk about address the needs to change. So, when do we meet needs to change? Needs to change implies means modifications or improvements to the existing system. Okay. We are working on an existing system and there is some need to change, some modifications are to be done, and what are the modifications or what are those improvements to be done onto the existing system? A control system model, the control system models actually help in this, and they originate in the control layer. And there are actually 4 types of these models, and we will deal with each one of them. We will kind of look into them what they are. So, the first one is called as the optimization model. Okay. So, the optimization models are defined as these models are used where analytics can be used to design, build and execute models required to make optimal choices. So, whenever you want to make optimal choices, the best set of the parameters when you have to do so, if this is the place where we use analytics to design, build and execute models that will help in making the optimal choice. So, if you use this model, it will tell you what is the optimal choice associated with that particular situation. Okay. So, here the most important thing is these models are trustworthy, models are quite trustable. Another aspect of these models is that most models are semi-automatic or fully automated. Semi-automated or fully automated. Okay. So, and optimization models are heavily used in industry to optimize the production, optimize the inventory, optimize this, optimize that. There are quite a lot of optimization does. So, and these models have a high level of trusting because of the rigor that is gone behind it, and also these most of the models are semi-automatic or fully automatic, because once you designed it and built it, then the execution aspect of it is mostly can be done with the help of a computer kind system. Second one we are going to discuss is the value improvement models. Value improvement models are built, these models are built and used for analysis and comparison of various options. Okay. So, we build these models, we build and use these models to analyze and compare various options available in front of us. Okay. It is not possible to do what? Not possible to develop optimal solution or optimal recommendations. So, the value improvement models does not help in doing the optimal recommendations. Why? Because most of the time the options are not exhaustive, because all possible options cannot be enumerated. All possible options cannot be enumerated. Okay. We cannot enumerate the entire option. So, hence it is not the optimal, but it is a good enough decision as far as we are concerned. Second part is that, so mostly involve search and compare options. Okay. So, you are basically looking for or searching for from some of the options that are available, what is the and analyzing these options, and you are kind of trying to say what from the available options this looks like the best option. But we do not know is there a better option available, because as of now that option is not considered. A classical example of this is like let us say there is 5 machines in a factory, and you want to maximize the utilization of a lathe machine. So, you do not really care about what is going on before the lathe machine and after the lathe machine. Instead, you look at the different options in front of you, like coming up with a faster tool or a quicker different tool bed, operating the process or changing the process using a different type of material, those kind of things. But doing that, how will it influence the other options, you do not really know. You might not even consider the option of coming up with a completely new manufacturing process. So, hence the value improvement models is focusing on what is available in front of you and how can you use that, what are other options available in front of you to improve the value of the existing process. Then what we have is the control system models continued. I said the next model is what we call as the experimentation model, and they are used in cases or in places where systematic improvement to the process is required through experimentation. So, what we are saying here is that we pretty much conduct experiments or controlled experiments are conducted, and these experiments and these are scientifically designed experiments. So, your aim is to systematically improve. You improve the process one at a time. So, graphically if you want to think about the experimentation model, it would look like this. Start at some point, it will improve like this. Systematically you will keep on, as time progresses, the performance of the system, you will keep on improving, you are systematically improving. So, you will go from current position to the next best, from there you will keep on improving. Some people also call this sometimes the continuous improvement models also, that it is also said in that way. But to do this you have to do controlled experiments, and these controlled experiments are scientifically designed, because from analyzing the data that you are getting from that experiments, you can use it to improve, or you can use it to improve the current state of the system. Also, second aspect is that sometimes natural, instead of controlled experiments, natural experiments are conducted where naturally occurring phenomena is studied. Naturally occurring phenomena is studied. So, in our case what we are thinking about here, you should understand here is that if you are trying to study the pollution in the river Ganga or the erosion of the banks of the river Ganga, then it is a natural process that is happening. So, you will go there, systematically collect the data. You will not do experiments, you just collect the data and analyze the data and come up with a model that determines the pollution of the river Ganga or the erosion of the banks of the river Ganga. It is not a controlled experiment, it is a natural experiment. On the other hand, a controlled experiment would be, we want to find out what is the best combination of fertilizer and irrigation to a particular field. excuse me, then what will you end up doing is you will take a you will take a you will divide the field into many small parts in which you would put the same type of seed, and you provide different amount of fertilizer and water to the different sections, and you see the output of it, and whichever area that gives you the best combination of the fertilizer, sunlight and water, which give you the best yield, that is probably the best setting for that particular thing. So, once you do that, then you will implement that across the whole field, and then you want to further improve it, then you will bring the concept of the weedicide, which type of weedicide you want to add into that. Then you systematically do the experiment on the previous setting to find out which setting work for the best weedicide, and you continue like this. So, such type of models were scientifically designed experiments, which are controlled experiments, that is the another aspect. So, we can do controlled experiments or we can do natural experiments. Then comes the next one, which we call as the survey models. So, survey models, the idea is that uses survey or feedback instruments to assist the decision making. This is quite common because many of us have seen this. When you are done with a particular, like when you finish an air travel, the airlines will send you a survey saying that please fill the survey and tell us what was your experience about the air travel. Did you like the cleanliness of the aircraft? Was the crew courteous to you? Was the food good? All those aspects comes out of this. And based on the feedback that is provided by the customer, and all those feedbacks are collated together, and from there they analyze and figure out whether the customers were on an average satisfied by the service provided by the airline agency or not. So, that is called as a survey model. Then the next one is what we call as an expertise model or expert model or expertise model. These are used in cases where expertise is available in the form of past experience or prior experiences. Okay. For example, if Airbus, a company that build aircraft, they want to build a new aircraft, they will definitely take from their prior expertise on building other airframes. So, they might like to, let us say they want to build a like a regional jet kind of a thing, then they will take one of their existing smaller aircrafts, and then they try to convert it into a regional jet aircraft, because they are trying to draw from the past expertise. They already established that this airframe is pretty good. So, then from there they can use that expertise that they gained in building that airframe, and then they build a new one out of it or modify it out of it. Okay. So, the big thing is that here the historic data is combined with personal expertise to guide the decision making process. So, you will probably find the chief designer decision making process of Airbus being asked, okay, we want to build this particular thing, here is our historic data, now you advise us what to do. So, this type of models where the past expertise is used to do something in future is also it's also part of a control system model, because you are trying to build capability again here, okay, operate or make the system better. Then the last one is what we call as the workforce model or the workflow model. Okay. The workflow model, these are defined by Saxena and Srinivasan as those models that are used to observe and govern the process. So, the aim here is that you are going to observe and govern the process. Okay. You can also think as day to day models. Here you are trying to think about the day to day operations of the system, and you are focusing on the analysis or analytics that will help you in doing the day to day operations in a better way. So, the main aim of this is used for allocating resources and also and also to generate alerts for corrective actions. So, if we decide that today we have to build 10 cars, so Tata decides today we are building 10 cars, then which are the people who will be working on getting the 10 cars? And if during the process, if we see that one of the painting job of the car is not doing very good, then we generate an alert saying that the people who are working in the paint shop need to be more careful about this aspect. So, this is the workflow. So, that we are worried more about the day to day operations. So, collecting data, analyzing data for managing the day to day operations is called as a workflow model. Okay. So, these models are also used for what we call as a day to day operations management. Okay. Answering questions like who should do what. Okay. Is it being done properly? Okay. Any change necessary? All these kind of things are considered as part of the workflow models. Now, the obvious question is that why do we, the one thing that we will always ask is why are these models classified so differently? What is the need of classifying the models so differently? The reason is the models that are operated at different levels have different objectives and thus drives different decisions. So, the models that are built at different levels, okay, whether it is at the network level or the control level or capability level, they will have different objectives. The objectives of the models are different, even though they might all be trying to do the same thing, and hence it will drive different decisions. So, let us take an example. Let us take the example of what we call as the pricing model. Okay. This example is provided by Saxena and Srinivasan. In the pricing, if we look at it at the network level, the obvious question will be like one of the thing will be how will it, the objective will be how will it affect the market share, okay, or it will be like how will the competitor respond. So, the pricing decisions that are to be done at the network level are at this case. If we increase the price of the product, is it going to reduce the market share? If we increase the price of the product or decrease the price of the product, how is the competitor going to behave? How is the competitor going to do that? So, that is the one aspect of it. Now, if you look at it on the capability layer or capability level, the thing would be like can we build or do we have the capability to build the pricing model? The question is, do we have that capability? Okay. If we do not have that capability, what do we need to do to build that capability? So, we said okay fine, we want to have a pricing model to be built to predict the or to increase or decrease the price of the car. Then do we have that capability? If not, what do we need to do to build that capability? But at the level of the control system or the control layer, control level, what we do is that here the aim is that design and monitor design and monitor the capability that was built, that was developed for creating pricing model. So, here what we are doing is we are trying to see, okay, fine, we are go ahead and decided to build the pricing model. We are decided to put in the capability to build such a model. Then the control level will be to monitor whether this capability that we built to develop the pricing model, is it working properly? Is there anything need to be done? Is there something going on wrong? If so, what are the changes that need to be made? At the workflow level, lastly, workflow level, the questions is more about the customer is coming, providing a price to the customer. Price could be a negotiation also. It could also be about sales negotiation, etc. So, if you go to the shop and says, I am going to buy one car, okay, here are the discount. I am going to go buy 100 cars. So, they might come across a different discount pattern, but that is done at the sales manager at that particular level also. It does not have to go to the CEO of the company. So, the workflow level, it will be more about dealing with the customer on a day to day basis, whereas the control level is about monitoring that pricing model. The capability level is the question of whether we want to build a capability or not. And in the network level or the strategic level, where we are talking about is that by changing the pricing, how is it going to affect how is it going to change the market share of the company. So, the same question of the pricing at different level will have different objectives. So, that is why models are classified differently, and because at different layer it has different objectives, the associated analytics associated with that objectives are also different. Now, coming to the conclusion of today, we need to just talk about the stakeholders in the decision making, and in this case we are going to talk about just the three important stakeholders in the decision making. The first one is called as a decision maker, and decision maker for us is the person, it can be a committee also, the person who bears the responsibility and accountability and accountability to make rational decisions. So, here the decision maker is the person who is responsible for making the rational decisions, and is also accountable for the rational decision making. So, typically decision maker is a leader. Okay. And because, why is it called as a leader? Because the decisions influence the organization. So, the person with whom the responsibility and accountability to make rational decisions is basically called as a decision maker, and that is the person who makes the decisions and with whom the responsibility of the decision remains with. The second one we are going to talk about is the advisor, which is the person who advises the decision maker to make rational decisions or assist by advising. It could be a person or it could be a committee, could be a group. Okay. So, typically the job of the advisor is to provide advice to the decision maker, so that, or provide advice that will assist the decision maker in making the rational decision. Then the third one what we talk about is the analyst. Okay. So, they support advisors Typically analysts are multiple, advisors or work on their own. Okay. So, sometimes analyst can be the advisor. This is possible. Sometimes the analyst can play the role of the advisor. Many organizations have analyst as a staff function. When we say it's a staff function, what it means is that there is a dedicated staff who will do the analysis and come up with an analysis, and on that analysis is transferred on to an advisor who will look into that analysis and interact with the analyst, and then that advisor based on these data will update the decision maker and advise the decision maker on how to make the rational decision. So, these are the major three stakeholders: decision maker, advisor and analyst. And we are basically, this course is primarily focused on how the analyst will do things, so that the feedback goes into the advisor and to the decision maker. With this, we actually conclude today's lecture, and from tomorrow onwards, the next lecture onwards, we will actually look into data, the types of data, scales, sampling, hypothesis testing, statistics, display of data, and those kind of aspects. So, I hope you guys have got the basic foundation necessary to understand and appreciate why analytics is required for practitioners to address different problems at different level of decision making. As you move up and down in the corporate ladder, your decision making responsibilities and accountabilities will change, and depending upon the higher you go up in the corporate ladder, higher will be your responsibility and accountability, and hence it is usually better to depend upon data driven decisions, or data and appropriate analysis to take this decision, so that the decisions come across as rational decisions. Thank you for your patient listening, and we will see you in the next class.